again. I think I already gave my intro. I can do it third time. This is Sanchay Mittal, and I don't know if mic is working or not. I'm gonna shout it out. Yes. So we are building cross-chain domain applications. Everyone is aware of dApps. I'm assuming that's the case. Everyone is aware of how the smart contract works. If not, we will go through that. Don't worry at all. But let's start with the mindset that if we are building a dApp or any applications, they are not existing only on Ethereum now. We have Polygon, we have Optimism, we have multiple chains which are coming up, and they have their own incentive. The whole liquidity segmented is all across these chains. One has bigger or one has another. These they have these incentive which are run multiple times, and that's why people are getting more and more interested in ZApps, or we call it cross-chain dApps. Let's start with a basic intro, which we will be using these terminologies a lot. We are not going to say chain because we know that there are multiple networks which are not exactly a chain. They are we can categorize it in a protocol, or it could be a roll-up which is very dedicated to a specific problem. So any L1, L2 sidechain and non-EVM compatible, we'll just call it domain, right? So I'm assuming you guys are with me right now. And as I said, xApp is a cross-chain domain native app. So any application which we will be building right now is going to be a cross-chain app. That means it is available on Ethereum, Polygon, any of the EVM chains, any of the non-EVM chains, as long as we are supporting and we are chain agnostic, as long as it's secure, right? So let's start with the second part. Yes, we are a bridge. And people have this question, are we secure? Is it, we have seen a terrible year last year, and we saw 3 billions of hack. And are we the same? No. But everyone says that. So let's explain how we are different, but let's start with why bridge are unsecure, why we saw this 3 billion of hack, which happened last year. What happened is that there are bridges which use these trust assumptions, which are basically validator sets, multi-sigs. So you are depending on these 10 people. Okay, can I bridge my $1 million and I will trust you guys. Okay, you three, I love you, and you will take care of me, right? And that's the trust assumptions which we are making with these stupid bridges which are using multi-sigs or validator set. That is simply third party. And how we can stop it? And yes, there were some code bugs which we have to make sure that we have simply much more large audience. We have these TVL caps, and we have much more audited power. Audited contracts, so people can go through that and they can report any security issues which they are seeing. So let's jump on to why Connext and how we approach this problem. So Connext uses modular stack. We don't create any new trust assumptions. We are not adding any sort of validator set. We are not adding any multi-sigs. What we are doing, this is the interoperable trilemma. If you guys are not aware of, I'll run through you very quickly. So everyone, if people don't know about scalable trilemma, that's okay. So when we are talking about interoperable trilemma, that is where we are talking about trust minimization, generalizability, and extensible. So when people try to create these bridges, they try to take these shortcuts where they do trust assumptions and try to avail generalizability and extensibility. So they can use a common interface for the bridges, and they can have a bunch of money goes from one side to another. But don't never think about the trust minimization. But we as Connext, we take pride in it. We absolutely take pride in is that we 100% focus on trust minimization. We make sure that this is happening, and then the user interface or the user experience. Yes, it's very important that if it's going to be horrible, I'm like, you are secure guys, but that's a shit show, right? So we want to make sure that we have trust minimization, we have good user experience, and how we can expand it to more chains. How we can make sure that anyone who is coming cross-chain can easily come and they don't even think about it like, okay, which roll-up or which chain I'm using. I just have these 5 params which I have to put in, and I'm all done. all good. So what we do is that first, let's start with how we are focusing on security. We focus on security by using transport layer, which are underlined, which are present for these bridges. So we don't create a new messaging layer. We use these existing messaging layer, which are pretty secure already, or they are the securest one for those bridges. So when I'm talking about Polygon, the POS tech is the securest. They use validator set, but that validator set actually runs the whole chain. So even anything happens to POS tech, the chain will dissolve itself, right? So the POS tech is the securest one right now for Polygon. And same when I'm talking about Cosmos ecosystem, it's going to be IBC, right? And when I'm talking about rollups, it's going to be rollups. So we uses that as a transport layer, and then when we have another security layer above it, where we have watcher set. Whenever you are sending a message from one side to another, when we are receiving this message from Polygon to Ethereum, we have this watcher set where we have 20 minutes where you can make sure that, okay, anyone sees that this information is not correct, guys. Even if you are using AMB, if it's falsified, we can make sure that doesn't happen to us. We can report it and stop that bridging which is coming up. So running through quickly how we can do it, we have pause button. So on each contract, we see that something is going wrong. We have this pause button, press it, stop, right? Nothing is stolen, everything is secure. We have TBL caps. We make sure that we have a TBL caps. We know that we will start with like some TBL cap. And once we are increasing it, we will have another audit. We'll run through the community that please, if you see anything, report us. We have incentive for them. And we have fire drills, which we run through every time where we see that if anything happens, how we can do it. I mean, you have to run through it, right? You have to be prepared. If anything worse happens, we have to be there. And formal verification, additional audits, we do it all the time. Generalizability, we have an arbitrary message passing. That means that you can pass any message. It could be any piece of information. It's not only token. It could be NFT. It could be a simple I love you message. I don't know. Anyone wants to do that. And if they want to send like do a DAO governance, they want to see like, do I send, if there is Aave in case right now, we have Polygon, Ethereum on multiple chain it's existing, but how do they do DAO governance? They can use cross-chain and they can have the voting mechanism properly done through this. So, and extensibility, we are present on all the chains. How Connext works. So it's very simple for a user or a DApp developer. What they have to do only is that use this XCall. I will run through the interface itself. They have to go through the XCall, and that's all is needed for the DApp, right? You have these 7 params you have to put in there, and everything is taken care of by the Connext. You can absolutely understand how the architecture works. And we have these active LP providers. What they do is that they see, okay, there is a request of completing this message. I will run through it. I will wait for the messaging layer for 1 and 2 hours. But for users, for the DApp, it's going to be 1 to 3 minutes at most, right? So you're having these transactions which are happening from Polygon to Optimism in 2 minutes in a single call, and you can have like multiple features available. You can put it in the encoding, and you can have like a Uniswap trade happening. You can have like abundance of use cases available where you can do anything cool in a single call, which can happen in 1 to 2 minutes, right? Let's run through how we can do this. So let's start that 10 minutes, which is on the clock. She'll be on the xApp. So why? It's one-click UX, as I explained. Better liquidity. What we have right now, we can avail better liquidity if we know that there are incentives provided to the routers and there are users who wants to use it. Cheaper and faster transactions. Of course, if you go like each and every chain, it's going to take like a huge time. Apps also, it's not going to be cheaper at all. You have to make these 3 to 4 or 5 calls where you have to execute it, right? You go make Polygon, Ethereum, Optimism. On Optimism, you make a swap. So 4 calls already added, right? 4 transactions already added here. We are doing arbitrary message passing, so you can do a lot cool stuff, and that's what it is. And we don't pick anyone winning. We are chain agnostic. Users are going to use these multiple platforms, so we have to make sure that we can actually onboard a lot of users and that's for the dApps, right? And we have a unified interface for all the chains, so it's not going to be different for anyone. And we can pass, as I said, we can pass any message, and that will that can be encoded into call data. Okay, so I will run through really quickly how we can do everything on these slides. I was gonna do a live examples. That would have been so cool, but the internet is not working over here. So let's start with the anatomy of a xApp. When we are talking about these, that one simple use case of interaction would be that you can use simple XCall, which is available on Connext.so. You can provide the parameters, and then you can execute it. Another one is that you can have something cool over here happening on source.so, right? You can have some functionality over happening here, and then you can transfer the money. So you can maybe do some swap which happens over here, and then you can use XCall, and then you go over there and then do another swap, or anything, whatever you like, right? And let's jump on to what we can build with this, right? I will run through this really quickly, and I will put in we have these code examples where I will explain how exactly you can do it. It's over here, right? So what we can build, we can do token bridging. We can do simple XCall where you have to transfer your money from one chain to another. You can have cross-chain governance where you can do voting, yield optimization. So Ethereum has already consumed everything, any best APY which is already available. So let's find out cross-chain, right? We can have really better APY which is available on Optimism, Arbitrum, or any other chain which is popping up right now, right? They provide these incentive for the users to come and provide the liquidity over there. So you can get much better APY all across these chains. DEX arbitrage, you can have different swaps rate. DEX liquidity, you can provide the liquidity to the DEX. Again, better APY. Cross-chain vault strategy, it's really cool. Really, really cool. So if you have these vaults and strategy management, you can have these funds which are already available on these multiple chains and can execute really, it's more like LP providing, as well as you can have these strategies which are already given through Yarn, possibly, and you can, it's really amazing. I'll go through that in one sec. And we have these cross-chain loans, so you can borrow on one chain and provide pay on another chain, right? We have cross-chain NFTs, so let's make it cross-chain, right? So if we have an NFT on Ethereum, we may want to use it on a game on Optimism, or the marketplace is going to, the gas fee which is provided on Polygon is going to be cheaper. So we want to make a marketplace which is available on Optimism. We can trade on Polygon. So once we have these things cross-chain, we can have much more functionality available. Guys, I know that we don't have internet, but you can scan the QR code. You can start with this template, which is available on xApp Starter, where you can, I'll give 10, 20 seconds, just scan the QR code or read the link or click a pic, and then you can go through that later on, right? Okay, yes. So, connect with us, but we can show this QR code later on. Let's jump onto this straight on the code side right now. Yes. So we have docs, which are available. You can open that as well. Quickly click a pic, and I will just go through the next slides. Awesome. So when I said XCall is the main function which dApp or the user needs to understand, or user doesn't even need to understand. dApp needs to understand that. So we have this XCall function where we have these 7 parameters which you need to provide to make any cross-chain call, right? So you're providing a destination chain where you want to execute this function or where you want to receive these funds, and then you have these target address. This is to address. So it could be a receiver address, or where you want to execute a new functionality, that would be your target address. ERC20, the token which you are transferring. If it's not related to token, you can address 0 this, and you can send any arbitrary message through that. Delegate, this is the safe functionality if something happens. I will go through that later on. Amount, slippage, and call data. Call data is one of the main where you can actually encode something. If you are not encoding, it's a simple transfer. You can just 0x it. Slippage, maybe mention 3%, so we know that if it's going through the AMM, we wouldn't suffer loss. So there are like two types of billing, which would be simpler for you, which we can do. That is XCall through SDK, so you don't even have to jump on the contract side. And if you are doing the contract integration, that is going to be asset transfers, unauthenticated calls, where you don't have to know on the target side from where this call is coming up. Let's start with SDK. It's pretty simple, right? So we have these X calls available. We are doing an approve for the token, and once we have done that, we are simply creating a call, X call, using the NXTP SDK base. So you can download the SDK, you just create this simple call, and you're done with it. And that's all. You are already a cross-chain app. For this, as I said, there are like lots of functionality. I will mention one of them, which is like very popular to you guys, is that DEX arbitrage. So if you're talking about a price probably of ETH, and on Ethereum, it could be way different on Polygon. It could be way different on Optimism. And you have to spot these DEX arbitrage, and you can make a good trade. You can make money out of it. And that will happen in 1 to 2 minutes. So you spot that, you make these transactions, you earn money. And that's what the DEX arbitrage is going to be about. This is a simple transfer, as similar to the SDK, but we are not using SDK. We simply want to use contract. You can just encode everything which is happening over here. So you have alliance happening, you transfer the tokens, and you have the approve happen. You just XCall it. Let's jump on to the really cool part. So, as I explained, initially we had the source contract, we have these target contract, right? So in source contract, what we are doing over here is that we are sending a simple message, that is a new greeting. We are sending a simple hello world over here, and we are just creating an XCall over here, right? So when we already saw, like, if you want to transfer a token, that can happen, right? That can easily happen. You just put where the address 0 is, you can put the token address, and you can put the amount. And that's what is needed. But when we are sending an arbitrary message, you don't even want to use the token transfers, you can do this, where you can simply have these target contract created, where this is going to exist on destination chain, and this is the target address which will be on the source contract. Once you do that, you are simply checking that, okay, did I receive like suffice amount if you want to, and you can receive the message by simply decoding it. So you encode the call data, you decode it, and send it to the function. So we have a very simple example where we are sending a simple message, but just think about this. If we are encoding a swap data for Uniswap, and we are sending that, we are encoding that and decodes over here, and then we process that function further here. So you can put any functions on the destination side and easily can execute it through this. So you can, you're talking about a 1 to 3 minutes of execution, where you are doing, in practical, where you have to do 5 calls, 5 transactions, if you are not cross-chain, and you can do simply through this. And yes, these are the 3 examples which I'm providing over here. Where can you do yield optimizations? You can spot the best yield out of all the networks, can earn more. Cross-chain loans, you can borrow one side, you can give it to another side. Think of it this way. We have a position created on Ethereum, but I have funds on Polygon, right? So I want to I would just want to like send the funds from Polygon and complete my position on the Ethereum. And that can happen in single call. That's what the cross-chain loans are about. Cross-chain NFTs, I've already gone through this. There's another part of this. In the target contract, we can have authenticated target calls. So sometimes we want to make sure that this call, where it is coming from, we want to make sure that this is the address I want to transfer, right? So the source call, source address where I'm receiving that, I want to make sure that on target that it is the one. And that is required in case of cross-chain governance, or in case of cross-chain vault strategies, and even in case of cross-chain NFTs, where I want to make sure that from where I'm receiving this address, these funds or these NFTs, or I'm getting a call of executing or transferring the funds from this destination to like a C chain, that is coming from this source address. And that time we have to use this authenticate call. So here we have a modifier where we are putting only source, and we are sending these origin sender and origin. That would be a part of the reconcile call, which happens underlying the bridge, and it will provide you the address where the call came from. And that's what will authorize that, authenticate does. And that will take 30 minutes. So you have these two cases where you can execute things in 1 to 3 minutes, and where you have use cases where you can do 30 minutes to 1 hour, depending on chains. So you have these two really cool ways to actually implement multiple ideas. Thank you very much, guys. That's all from me. We can run through all the ideas. I would love to hear from anyone. If you are online, you can send us these ideas on the Discord, which is available on the Connext. So you go to the Connext.network, you connect with us on the Discord, and we can chat more over there. Anything else? I would love to hear the questions right now.